Good morning, boys and girls. Okay, we are on the topic different forms of energy. Okay, so in the last video, we have seen some forms like mechanical energy. Okay, I am revising it again. It is the energy produced by moving an object. Okay, like in machines, we move a part and then that part uh, moves the other parts, okay, multiplying the energy or transferring the energy to other parts, and that's how the work is done through mechanical, okay, through machines. Okay, now kinetic energy, the energy produced by the uh, virtue of motion, okay, by the virtue of its motion. So that is kinetic energy. Now potential, the energy produced by or possessed by, you can say, by virtue of its position. Okay, so I had given you the examples. If a spring is compressed, it has potential energy in it. Okay, and if an object is lifted high, then it attains potential energy. Okay, that's how that energy is there. Then the sound energy, the energy produced by vibrations, okay, by vibrating uh, strings or a film or anything, okay, so that energy is produced. And by sound energy only I am uh, communicating with you, okay. So now my sound is converted to electrical, then it is transmitted, and you again it is converted into sound energy. That's how you get my voice and videos, okay. So this is how sound energy. Okay, then chemical energy. Okay, when there is a chemical reaction, in chemistry you must have studied, either it absorbs energy or it releases energy. So two types of reactions are there, in chemistry, exothermic and endothermic. So this is how by chemical reaction uh, energy is produced. Okay, when we are cooking food also, we are using LPG, burning it, that is a chemical reaction and heat energy is produced. Okay, same way we can react uh, some of the substances to produce energy. Like here it is given. Vinegar and baking soda, if you combine together, then energy is produced. Or if you uh, take a match to light, then strike a match against a matchbox, so energy is produced. Okay, fire is produced, light is also produced, so energy is produced. In batteries also you are using in your homes. Energy is stored there is chemical reaction in the battery. That's how the energy is stored uh, by the chemical reaction which goes on inside the battery. Okay, so now electromagnetic energy, it's a combination of heat and light energy. Okay, so all the lights you have seen, they are example of electromagnetic energy, including the sunlight, and that your LED lights or whatever lights you see, they are all electromagnetic energy. They are waves, they travel in waves which are called electromagnetic waves, which carry uh, energy. And remember here, the sound energy requires a medium, but electromagnetic energy, electromagnetic waves, do not require any medium. They can travel through vacuum also where there is no medium. Okay, so you can see sunlight is coming from so far without a medium. Okay. So examples are so many here. Okay, all the lights, even when the fire is there, from fire electromagnetic energy is radiating. Now electrical energy, energy produced by the movement of the electrons, okay, in through the wire or through your electrical appliance. When it flows, the energy is converted. Okay, when it flows through a bulb, light energy is produced, not actually produced. Energy is always converted. So electric energy is converted into light energy there, and when it is uh, passing through the fans, mechanical energy is produced, and the fans uh, start rotating. Okay, then you can see many examples, many uses of electrical energy in your home, in heaters also. Okay, in refrigerator, and lot of TV, CD players, and lot all of them. Then the next form is nuclear energy. So when an atom is split, okay, then a lot of energy is produced, a huge amount, okay, tremendous. So how it is broken, that is the question. So there is a process. Okay, so we'll not go into it. Is hit by a neutron, and then the nucleus of an atom is split, producing a lot of energy. And this energy is used in nuclear power stations also to produce electricity, and uh, in atomic bombs, then nuclear submarines, and sun also produces the energy by the same process. Okay, there also the reaction goes on this. Okay, where the atoms are broken. Split means they are broken into two parts. So in the sun, continuous reaction, this is a chain reaction actually. The chain reaction goes on, and it is going on the sun, producing a lot of energy. Then the solar energy. We have already seen electromagnetic energy. So the same way the sun is radiating energy by electromagnetic energy. We can call it by a different name because it is the most important energy, form of energy. In fact, most of the energy, if not all, is coming from sun only, directly or indirectly. Okay, there is conversion going on the earth, and the energy comes from the sun only. Like if we are eating food, so that's how we are getting energy, and that food are produced from the plants, and plants get energy from the sun. So either directly or indirectly, we are getting the energy of the sun only. So that is the solar energy, and we are using it now. We can use it directly also in solar heaters or solar panels. We can charge our batteries, solar cookers also, solar heaters, and a lot of uses are there. Okay, we can collect this energy or convert this energy into different forms for our use. Okay, so that's the most important form of energy. Not most important, but the main source of energy, you can say. Um, So these are the forms of energy, some of the forms of energy, not all. We have some other forms also. So in your syllabus, these are the forms given. Now our next topic is interconversion of energy. Now you know the law of conservation of energy, that energy can neither be created and nor be destroyed. So there is only interconversion of energy, and there are a lot of examples given in the book. Okay, so mm, potential to kinetic will take first. Okay, you must have seen your doors, the example given in the book. The doors having a spring. Okay, when you open it, you apply some force to open it or spend some energy. Then that door gains potential energy in its spring. Okay, so and using that potential energy, again the door shuts, goes back to its position and shuts the door. Okay, so that is it is changed into kinetic energy. First, it is the energy we have used pushing the door. It stores there as potential energy in the spring of the door, and then it uses to shut it again, and that's how it is converted. Uh, it is then again used as kinetic energy. Okay, then the swinging of a pendulum. Okay, swinging of a pendulum is a very good example to understand potential conversion. Okay, I had drawn an okay here. Okay, for the last chapter there was also a pendulum. So here I will use the same figure. Here, okay, first of all, this is a pendulum at rest. Okay, now here there is no energy, but we take it in our hands and take it to this position. So here it attains some height. You can see the height difference here. This is the height here. Okay, you can see this much is the height. So there is potential energy here, potential energy. Now, when we release it, when we release it, the potential energy changes to kinetic and the bob starts moving. And here at this position, the uh, it has the maximum kinetic energy, the maximum velocity it has. And again, it slows down, and here the kinetic energy is again converted to potential energy at this position. And again, it comes back changing to kinetic, then to potential, then to kinetic. So that's how the uh, kinetic and potential conversion goes on. Okay, and the pendulum moves on. Okay, now we'll take some more examples going. Okay, mechanical energy to electrical energy. This is, you can see in generators. Okay, so in generators, a motor moves on. Okay, and the current is produced. We will not go into detail because we'll come to this topic in detail in later on in the Okay, in your book it is there. So okay, this is okay by this is mechanical energy where uh, the turbine, or you can say it is rotating. Okay, by rotating rotation, we use some fuel, okay, diesel there to rotate, and that's how there is magnet and electromagnet, okay, magnet, and that magnet produces energy, electrical current there. So we'll come to detail later. But the conversion, let us come to the conversion only. So here we are using the mechanical energy to produce electrical energy in generators. Okay. Uh, okay, for today this much is enough. Okay. In the next class, we'll discuss the other conversions. Okay, so you read them nicely. Okay, this is interesting, very interesting. In fact, physics is very interesting. So go through these pages. Okay, this is 29 and 20, 30 page, this also. Okay, you go through this page also in advance. So you'll understand it better and you will take interest also. It is interesting. And you can find some other examples also. You are always playing games in your mobiles. So if you use that mobile for to find some examples, it will be very interesting. Okay, so just do it, and we'll do the other conversions we'll see in the next class.